Hello, guys. So, this is our chapter on arithmetic series and sequences, and we are going to cover the basic topics on this, and we are going to explain you what is arithmetic sequence, what is arithmetic series, how do we take some of these, how do we find terms, what the questions in the exam are going to look like. Yeah, okay, so let's start. Adjust this a bit. Okay, so first we are going to start with arithmetic sequences, not series, so I can maybe write it as sequences. Okay, so what is a arithmetic sequence? Okay, let's say we have a list of numbers. Now when I look at these numbers for patterns, I need to look at how these are related to one another. So as I can see, the difference between them looks like 4. So that is a arithmetic sequence. A sequence where the difference between each term of the sequence is a constant. Okay, so let's see. You can see the difference is plus 4 every time we go from one to the other one. Okay, I can even show you, like, see, like, the difference between these two is 4. And so on and so on and so forth. So every time the difference just remains constant. This is what we call a arithmetic sequence. Okay, now we can introduce some terminology. So what does everything mean? Okay, so the first term that we have in our series, we write it as A. So we call the first term A. So in this case, A is going to be 3. Now how do we represent the difference between each term? We call that by D. So we can say D in our case is going to be 4. Okay, and what's Tn? So like any term in this series is going to be called Tn. We are just using this notation to represent any term in the series. So based on this, if we try to think what is a general formula that can tell us what each term is going to be. So here I can say the first term is going to be A, but how do I determine what the next term, what the next term, what the next term is going to be? So if you imagine, we can write this as something like something like 3, and then we can write this as 3 plus 4, and then we can write this as 3 plus 4 multiplied by 2. So you see, 4 multiplied by 2 is 8, and 8 plus 3 is 11. So this is the way we can write our series, and it will go on. It will just go on like this. So it will go on to 3 plus 4 multiplied by 3. So based on this, if we try to generalize this, we see that 3 is common across each term, and the difference is getting multiplied depending on which term it is. So if it is second term, the difference is getting multiplied only one time, and so on and so on, so on. So based on this, can we say that the T of n, any given n term, is going to be A, the first term, plus n minus 1 t. Okay, so what is n minus 1? So like, let's say this sequence just goes on and on and on. So any given term which we are talking about can be called T of n, and it is going to be n minus 1 d. Okay, I hope this is clear. And this is the general formula that we use for arithmetic sequences or series. And let's keep this inside as we are going to use this more during our lecture. Yeah, okay. So let's go ahead. Okay, you already know. Okay, so we can say the difference is also the difference between the second term and the first term, which is 4. So for this particular series, what is t of n going to be? The t of n is going to be 3n minus 1 multiplied by 4, that is going to be 4n minus 4. So our t of n is going to be 4n minus 1. Remember, this is just something we derive for each sequence that we are talking about. So in future we will have different type of sequences, and each particular sequence that we are talking about will have a different formula for t of n, and this is a general formula that we can apply to any arithmetic sequence. Okay, we can check our formula while when we are doing this in the exams. We can just check, okay, is our formula same? So let's say t of n is equal to 4n minus 1, and here we have 15, and this is n of 1, 2, 3, 4. And if we put 4 here, so if we put 4 here, we can see that it is going to be 4 multiplied by 4 minus 1, which comes out to be 15. So see, our formula is working correctly. Okay, this is just a sanity check we can do to check if the formula which we have derived is correct or not. Okay, now how do we use this formula in questions, and what the questions are going to be like where we apply this formula, and how it can be applied? So it can be applied in both directions. So for a given sequence, I might be asked, for in any given sequence I might be asked that I want to find t of 56th term. Let's say somebody wants me to find a t of 56th term. You understand? So like calculating a sequence till 56th term without a general formula is very tedious and not something a lot of people might do. That is why we have these general formulas. So of course we can use this formula to find the 56th term directly. Or there is another way where we can check if a given term is in a sequence or a series or not. Okay, let's first look at how we can use this to find any term we want. Okay, given a position on the sequence, now we can say what the value is using this formula. So let's say t of 25 is going to be 4 into 25 minus 1, which is 99. Okay, so we now know that this is 25th term. Okay, and we can also do this backward, of course. So if we are given a term in a sequence, if we are given t of nth term in any sequence, we can tell what position it occurs at. So we have this simple formula, so we can determine n if t of n is given, or we can determine t of n if n is already given. Of course, a and d is something which you are expected to derive from looking at the series yourself. Okay, so let's see, 4 of n minus 1 is equal to 99. So in this case we set the value, the nth term is 99, tell me at what position it is. Okay, we do this, we derive, then n is as 25. What is the 72nd term of the series? Okay, so now this is example. Okay, we have to find the 72nd term for this series, and now we will start by looking at the difference. The difference between these two is 4, and the difference between these two is also 4. Just what is changed? The thing that is changed is a. Okay, the starting term for this series is changed. So based on this, what the formula is going to be? It's going to be, what is the value of a in this case? It is 2 plus n minus 1 d. D is going to be 4. Okay, so this is 2 n minus 1 4, which turns out to be 4n minus 2. Am I right? Okay. Okay. Yeah. See, so from this we derive 2n minus 1, and this is 4n minus 2, and then we have 4n minus 2, which is 75. Okay. 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 Now we are asked, is 72 a given term of this sequence? Okay. So we have the general formula, which is 4n minus 2, which we just derived, and we have 4n minus 2 is equal to 72. Now we will put 72 as t of n. Let's try to find the n for which 72 will be in the sequence, for which we get the answer of 18.5, which, as you can guess, is not correct. There cannot be a term in a series or a sequence as 18.5. We will have the first term, second term, third term, fourth term, and so on. But we will not have terms that are partials or are in fractions. So we can say 72 is not a term. Continue with this. Now we are going to talk about two very common exam twists. First, the term are given as expression in x. So you don't even know the numbers yet, and we have to find the actual result of this. Okay, so let's see an example of how a question might come in the exam. Okay, so this is what is being given to us. So this is a arithmetic sequence. They will tell us if it's a arithmetic sequence or if it's a geometric sequence or if it's something else. But this is a arithmetic sequence described in terms of x. Okay. So we have one variable in this sequence, and the way I want you guys to think about it is, for one variable, how many equations do we need to solve it? The answer is 1, right? If we have one variable, we just need one equation to solve it. Okay. How can we form an equation using these? Okay. So I know one thing about arithmetic series is that when I go from here to here, or when I go from here to here, the difference is always the same. So this is going to be D, and this is also going to be D, and this is also going to be D. Okay, so can we form an equation using this? So let's say 5x minus 2, this term minus this term should be equal to this term minus this term. Okay, let's try this. So can we say something like this? Now this term minus this term is equal. Hope this makes sense. So we have been given this, and this is something which is the basic definition of arithmetic progression. So any sequence or a series where the difference remains common is a arithmetic sequence or a series. Now we just use that information, we use that logic to come up with this equation here. Okay, and if we just solve it, so we are just like 5 into 3 15. So 5x minus 3x is 2x, minus 2 minus minus is going to be get multiplied, this is going to be plus 1, so this becomes minus 1 is equal to 4 minus 5 minus x, and this is going to be 5. Based on this, if we solve for x, we can determine that x is going to be 2. Okay, now what we have to do is take this x now what we do is we take this x and we substitute it back into the series. So what we do is we take this value of x and we substitute it back into the sequence that has been given to us. Okay, so when we substitute this back, what we get is t1 is equal to 5, this is going to be 5. If I substitute x is equal to 2, t2 is going to be 8 and t3 is going to be 11. Based on this, can I determine the value of a and d? I already know the d now, so the difference between these is 3 and the first value is a. So now we have a, now we have the value of d, and we can derive the general term for the series using this. If you guys want an example, I can write it here. So this is going to be 5 plus n minus 1d, which is going to be 3, and if we will open the brackets, this is going to be 3n plus 2, right? It's going to be 3n plus 2. Okay, so now we are going to deal with the next type of questions that we might see in the exam. So the first type was all the terms of the sequence were given to us as expressions of x. So each term was given to us as expression of x. Okay, now we go ahead and we see the another type of question. Okay, this is also a very common type of question that might be asked. It's two facts given and we have to turn each into an equation. Okay, so if we look at this, we have two variables in this, a and d. The n is the term on which this formula is dependent. So n is the term in which the formula is dependent. So n is already a dependent term for this. So the actually two things which are given to us is a and d, which we might have to find in this question. Okay, let's look at the question. Okay, so the first fact that has been given to us is t6 is equal to minus 5. Okay, let's see what other way can I write t6. Can I write t6 as a plus n minus 1d? So t6 will be a plus 5d. Okay, can I write it as this? Yes, sure, I can. Okay, let's call this equation 1. So in the question, another fact that has been given to us is t2 plus 8 is equal to minus 2. Okay, so we are saying t2 plus 8 is equal to minus 2. Can we write t2 as a plus d. If I put n is equal to 2 here, what is t of n going to be? T2 is going to be a plus d. Okay, and t8 is going to be a plus 7d. So we can do this here. If we put t of 2, it's going to be a plus 2 minus 1, which is just 1, a plus d. Okay, and t of 8 is going to be a plus 8 minus 1, which is going to be 7, a plus 70. And if we sum both of these up, what we get is 2a plus 8d. Okay, we will call this our equation 2. This is 2a plus 4d minus 2. Okay, and we are going to divide. We can see here that this equation has 2 as a common factor, so we will divide it by 2 both on the left and the right side. And if we divide the whole thing by 2, then this is what we get. So if we divide the whole thing by 2, we get a minus 1 minus 4d. This is just a. And we also changed this equation a bit. We moved the d around to be on this side. Okay. So here I want you guys to carefully understand what we did and how we are going to deal with things like this in the future. So when the question will be given to you guys, it will only be given that the first term and the second term is minus 5 and t2 plus t8 is minus 2. This is the only information that will be given to you. So based on this, if we want to find the generalized formula for this sequence, I need to find the value of a and I need to find the value of d. N is the thing which is already dependent. In order to find a and d, which are two unknowns, how many equations will I need? Yes, I will need 2 equations. And we have been given with 2 facts. Okay, this is how we should be thinking about this. What are my unknowns and how many equations I need to make from that, and what are the number of facts that has been given to me, and we can convert each fact into an equation. So here what I did was I just converted this into a and d. I just converted it into the terms of a and d, and same for this one. I converted it into the terms of a and d also by adding this and this together, by adding t2 and t8 together. I added t8 and I added t2 together, right? And I just wrote it like that. And then we swapped d to be on the other side. Then we swapped d to be on the other side. Okay. So move it like that. What I did was I just moved d to this side. So if we move d to this side, this will become the same equation, right? So now I have 2 equations. All I have to do is substitute a back into d. So what I will do is I will take the value of a and I will substitute it back into the equation 1. I'll take the value from equation 2 and I will substitute it into equation 1. Okay. So I took this value of a and I substituted it into the first equation that we had. I substituted the value of a from 2 into 1. You can write stuff here like subst 2 into 1. Okay. Okay, let's clean this up a bit. Make all of this smaller. Okay. So when I substitute the value of a into this equation, what I get is minus 1 minus 4d plus 5d is equal to minus 5. So which will give me d is equal to minus 4. Now I will take this value of d and I will again substitute it back into this equation. See, we substituted 2 into 1 to get the actual value of d. We substituted a, so we got the value of d. Now that we have the value of d, we are going to again substitute it into equation 2 to get our real value of a. So when I substitute this back in, my value of a is 15. Perfect. So now what I have is my perfect value of a and d. And using this value of a and d, what I can do is if my value of a is equal to 15 and my value of d is equal to minus 4, I can now, using this, I can derive any term of this series. The first term is 15, second term is 11, third term is 7, and so on. Understand? Okay, so we are just going to substitute this back in. Okay, that's it. Okay, now we are going to start with the series. Okay, in the starting, if you remember, I explained to you sequences. So what is the basic difference between sequence and a series? A sequence is just a list of terms, and series is when we sum up that sequence. A series is a summation of that. So before we were writing everything in a way like 2, 3, 2, 5, 8, 11. But now what my series is going to be? A series is a representation of 2 plus 5 plus 8 plus 11. Okay. Okay. This is a sequence and this is a series. The same thing written as a summation is a series. Okay, now we need to define some more terms. Before we had with us, you can write it here. We had a, which is the first term. Then we had d, which is the common difference. Okay, so we have d as the common difference, a is the first term, and d of n is equal to nth term in any series. Okay, Tn is the nth term in any series, right? Now, as we talk about series, moving on from sequence, we will talk about what S of n and what L represents. Okay, so here we have a series. S of n represents the sum of the first n terms. So right now T of n represented that particular term in a series. It might have represented fifth term, it might have represented the last term, or it could have represented the second term. But now S of n represents the sum of all of these sequences from here till here. So if we sum all of them up, that is what S of n represents. If we sum up all of them, that is something the S of n will represent. So we can write it down here. S of n. Say S of n is equal to sum of k from this to large is the sum of first n terms, and L we call it the last term in the series. So now why do we have these, and what the questions in the exam are going to be look like? Just like we had a general formula for any term that appears in a sequence or a series, we need to find a general formula to sum up the whole series up to any n terms. So generally you will be asked to sum up a series for the first 20 terms, for first 15 terms, for first 500 terms. So now we will be driving a formula that will help us find this S of n, and we will have this general formula which we will be using throughout our sessions to do more stuff. Okay, now this is the most important part, and this explains to us why this formula works, how did we drive this formula, and how we use it. Okay. So, mathematicians are clever people. So the trick they use to drive this formula is very interesting, and let's look at it. Okay. So let's say you have a series, okay? You have a series like this, and it will continue till all the terms. So what the series might look like is, it will have, let's say, it will have t of 1, then it will have t of 2, so on and on and on, it will have t of n, which is the last term. We can also call it t of L, right? We can call it t of L, the last term. Okay. So now if I take this and if I write it in reverse, will that make a difference? No, right? No. For a series, will it make a difference? No, right? So for a series, whether I write it as 3 plus 7 plus 11 plus all the terms in between that it takes to reach to 39. So if I write it like this, will it make a difference if I take this and I write it as TL, TL minus 1, and so on. So instead of writing this, if I write this as 39 plus dot 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 plus 11 plus 7 plus 3, does not make a difference, right? In what order we subtract or we add terms, it does not make a difference. Okay, so now we are going to understand why we did this. Okay, why do we have something like this and how are we using it? Understand? we do need to understand how are we going to use it. Okay, so what somebody did was somebody wrote this series from front to back. Okay, so instead of writing everything like 3 7 11 39, we wrote it as 39 dot 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 11a. So this is just the same thing, just in reverse. You see, this is just the same thing, just in reverse. Just this thing is there, this thing will be there, and this thing will be there, and so on. And this term just came here. So we just reversed it. But now is the interesting bit. So when I reverse this, I can say both of them are equal to Sn, right? I am right about that. Both of them are equal to Sn, right? But you see a pattern here, right? You can see a pattern here. This D and this D. This is a plus D and this is minus D. See? So if we sum both of these together, all of these D's, all of them, they will be cancelled out. See? If we sum it together, all of these D's, they will cancel out. And what we get left with is just this. Is A plus L, A plus L, A plus L, A plus L. These are all n minus 1 terms. And this will also get added. So for every pair of this, we got one L and one A. And our D is essentially removed. So all we kind of did was, we wrote our series as an expression of L, which is our last term. We wrote our series in expression of L, and we arranged it in a particular way by looking at it that, okay, if I write it in terms of L, I get a lot of minus D terms across my series, which are completely equivalent to the plus D terms when I was writing my series as first term plus the common difference. And using this clever trick, what equation we made is 2Sn is equal to A plus L, A plus L, A plus L. And these, how many terms are these? These are n number of terms. Because here you can see for everything, I got one A and one L. For everything. For everything I got one A and one L. One A and L pair remains and the common difference term was cancelled out. Right? Okay. So can we write it as n A plus L? Yes, we can. So now we take this 2 and put it on this side, which gives us the formula Sn is equal to n by 2 A plus L. Okay. This gives us the formula S by 2 and A plus L. This is a very important formula that we will be using again and again throughout the course. I want you guys to really take your time with this and actually understand how somebody derived this formula. How to think and how to think in terms of series and how we in future can get these things for different type of series. Each series have a clever trick where we use some clever trick to cancel out a lot of terms and come up with a very simple generalized formula that can describe the whole sum of the series. Okay, and you can see how powerful this is. Imagine doing something like this without a formula. So if you had to sum up 15 terms like this, it would take a lot of manual calculation to calculate that. And this is what helps us, and this is what makes our life easier. Okay, and there is one more trick. I can tell L as T of n, right? I can write L as T of n. L is T of n, which is equal to a plus n minus 1d, which is just my normal term, right? T of L is equal to a plus L minus 1d. So if we substitute that into this formula back in, so we take this value of L, and we substitute it back. So what we are essentially doing, we are taking this value of L and we are substituting it back into our formula for this. We are just substituting L here. Just taking L and substituting it here into the same formula, and then we can get the summation of a series formula in terms of A and D. Okay, this is same formula but written in a different way, right? This is the same formula just written in a different way, where I have A and N and D as my terms. Okay, now we have to understand which formula we will use, whether we will use this formula in some questions or we will use this formula. To understand that, it's very simple. If the last term is given to us, we will use this formula. We will use the formula that contains last term. And if no last term is given, then we will use just our normal formula. Okay. Let's look at some examples regarding that. For example, we have this. We know the first term is 4. We know the difference is 7 by looking at this. 11 minus 4 is 7. 18 minus 11 is 7. We know this is arithmetic progression. And we know the last term is 368. So can we substitute it using this formula? You guys can pause and try it out yourself before I show you the answer. Yes, we can. Okay. Using this, you need to tell me the number of terms in the series. Okay. And we can find out the final sum of this. Okay. Now, this is another question. In this question, the last term was given to us. But in this question, there is no last term. And we have to find the summation of the first 20 terms. So, which formula we will use? We will use this formula. Okay. Try it out yourself before I reveal the answer. Write down the value of A. Write down what A is equal to. Write down what D is equal to, and then substitute it into these values. Okay, I'm going to reveal this now. A is equal to 15, D is equal to 6, N is equal to 20, S of 20 is going to be S of 20 is going to be 20 by 2, 2a plus this. Okay. To look at one last type of questions that we have for SN. So some questions, what they will give you is a formula for S of n, and they will ask you to find the series based on that. Okay, so for example, let's look at this first. This is something which will be given to you in the question. So in the question, they will provide you with S of n, which says that 2n square plus n represents the sum of the series. So the sum of the series is given to us in a form of n. S of n is directly given to us in the form of n. We don't have value of A, L, D or anything. And using this, we have to derive the value of A and L. So you might say that, okay, we have been given only one fact, and based on that, how do we find out two values? So we have to find the value of A and we have to find the value of D. But we are missing a key bit here, a key insight here. This is one fact that has been given to us, and the other fact that has been given to us, or we have to find for ourselves, is this. It's that if we have a arithmetic series like this one, okay, let me pull it out from the examples. If we have a arithmetic series like this one, let's say, okay, we have a arithmetic series like this one, then the t of n is always going to be the sum of the terms minus the sum of the terms in n minus 1. So if I sum up 3 and 7, and if I sum up 3, 7 and 11, and then I subtract the sum of first 3 terms from the sum of the first 2 terms. So if I sum up these 3 and then I subtract the sum of these 2 from it, then what will I get? I will get this term, right? I will get the third term which I want. I will get the term n3. So this is what I have written here in mathematical notation. T of n can be represented by s of n minus s of n minus 1. So now we have this and we have this. We have two equations and we have two unknowns, which is A and D. From here, it should be simple for us to find that out. Okay, so when I look at this, can I reduce n easily? Can I find s of 1? And there is one thing for sure, the sum of series for the first term is going to be same as the first term itself. So what I can say from that is that s of n is equal to t of n when n is equal to 1. So for the first term, s of n is going to be equal to t of n. So if I substitute n is equal to 1 in this formula, what will I get? If I substitute s is equal to 1, I will get 11, which is going to be equal to t of 1. Right? Now, as I have t of 1 and I have the Sn formula, based on t of 1, I already know what my value of a is. And based on that, finding the value of d and all the subsequent terms is not very difficult. Yeah. So what you need to remember is that S of n formula secretly contains the whole series itself also. So if you have a generalized formula that could tell you the sum of series up to a particular point, you can also use it to derive each term of the series using the fact that t of n is just that particular term summed up minus the sum of all the terms before that. Okay, so using that we derived s2 and we put it into the equation and we say sum of first two terms is 26 and my first term is 11, then my t2 is going to be 26 minus 11, which is equal to 15. Yeah, and so on and so on. Like this we can derive as many terms as we like. So we can take s3 and we know that t3 is going to be s3 minus s2, which comes out to be 19. And just like this we have arithmetic sequence with a is equal to 11 and d is equal to 4. Okay, so don't be confused when you see something like this and feel like, okay, I have been given only one fact and there are two unknowns that I have to find. We have the logic and the fact that our arithmetic progression is just a series where a constant term gets added one after the another. So Sn minus 1 is t of n. You can also put this formula here. Okay. General pattern that we are going to have is that we are going every time in a sequence or a series question, we will generally be trying to find the value of a and d, and then we will pick the formula that we like and we will substitute it into it. Okay, that's it for this chapter, and I would really recommend practicing and driving this yourself. This is the most creative or the clever part of the derivation, I would say. This is something which can make the logic and your understanding of this formula really clear, and then you should definitely practice questions of each type. There are links in the description. You can use CentroLearn to actually look at these questions and practice from there. Thank you.